While USB power delivery is certainly making inroads into the camera and cinema device markets, it has not completely displaced the simpler DC barrel connector, and, well, there's still a ton of devices out there that use it. So, what do you do if your device has a DC barrel jack for power and you want to power it from a USB power delivery, or PD, power supply? Well, the answer to that is you get one of these. This is a USB power delivery trigger adapter, or cable as it's sometimes called, but I'm going to just call them trigger cables regardless of the form factor for the rest of this video. These are fairly simple devices. They ask your USB power delivery supply for a specific voltage and then route whatever's provided by the power supply to the DC power jack that is on the other end. Now, they're often actually quite cheap because, well, they don't do any built-in voltage regulation or have any overcurrent protection. It's just a simple USB controller chip that talks to your power supply, and all that's being done by your power supply. However, that means to use these effectively, we need to know a little bit about how USB power delivery works and also what voltages our devices can tolerate. So, let's start by talking about our devices. Now, hopefully your device has the supported voltages that it uses or can tolerate printed on it, or at least in its manual. If it does, then that's all you need to know about what you need to know on the device's end. However, my experience, especially with camera gear, has been that manufacturers often don't provide all the details, or in the worst case, any details at all. However, if your device is battery powered, especially if it was designed for use in the film or video markets, there's a good chance you can figure out what voltages it can take or tolerate pretty simply. Moreover, most of these kinds of products, this gear, supports a wide range of voltage inputs because it's due to the nature of the film industry and the types of batteries that are used. So, for battery-powered gear, at least in filmmaking or camera-adjacent products, there are two common battery types that are used: small camera-sized batteries and large cinema or broadcast-style batteries. Now, for those large broadcast or cinema-style batteries, I'm talking about things like, for example, Anton Bauer Gold or V-mount batteries, and these batteries have a 14.4-volt nominal voltage. However, anybody who's ever done anything with batteries knows that the battery voltage changes with its charge state. The more discharged the battery is, the lower the voltage. And for a 14.4 volt battery, the range for this goes from as little as 11 volts when the battery's fully drained, all the way to 16.8 volts when it's fully charged, at least assuming it's lithium ion. This means that any device that's designed to use one of these batteries will be designed to operate safely anywhere with a voltage in that range. Now, for the smaller camera-style batteries like the Sony NPF or Canon LPE6s, that roughly halves the voltage range of the big cinema batteries. That is, their minimum voltage is usually around 6.2 volts, and their fully charged voltage is around 8.4 volts. Now, that said, in many cases, filmmaking gear that uses the smaller, lower voltage batteries, when you put a battery directly on the device, will be designed to support the higher voltage range batteries of the cinema stuff so that when it's used in a big rig, it doesn't blow up. So, for example, this Atomos Ninja Ultra is designed to work with input voltages ranging from 6.2 to 16.8 volts, even though it only mounts a little battery. Now, we also need to know a little bit about how USB power delivery works. We know what the voltage our batteries can, or our devices can take. Well, what can we feed them? And this is the part that gets a little bit more complicated. Now, since these trigger cables don't include voltage regulators, that actual voltage regulation, or the voltage that you actually get, depends on the USB power supply that you plug them into. For modern USB power delivery devices, this is ones that are either using version 2 or version 3 of the power delivery standard. It'll usually be written somewhere in the specs. There are two things that we need to know to be able to effectively use these trigger cables. Specifically, we need to know about what voltages we can actually get and when, and what happens when the supply can't give us the voltage our cable asks for. Now, to the first part, the USB power delivery standard defines 4 what they call normative voltages, and a power supply must support or supply all, or some, I should say, or all of these depending on its capacity. Now, the normative voltages are 5, 9, 15, and 20 volts, and that'll be what you find most USB triggers are, or power delivery triggers are designed to create. Now, as for capacity and what you get, well, all power delivery supplies will supply 5 volts. It's the bottom end of the standard, and it's required everywhere. A power supply that's rated for more than 16 watts will include, or I should say 16 or more watts, will include 9 volts. Power sources that are rated for 28 or more watts will have a 15 volt output or mode. And finally, sources that are rated for 45 watts or more will include a 20 volt mode. Now, this means that if you plug your 15 volt cable into a 20 watt charger, it's not going to get 15 volts because the charger won't have that mode to support it. So what happens then? Well, in this case, one of 2 things can happen. One is that the device rejects all the available voltage profiles and no power is supplied. And this is what a camera like the R5C does when you plug it into a charger that can't supply what it asks for. Alternatively, and this is what almost all trigger cables do, the device can accept a reduced power at a lower voltage. So, for example, your phone does this whenever you plug it in. It doesn't care what the supply can supply. If it can't supply the maximum amount of power the phone uses to charge, it just charges its battery slower. And as I said, this is what most, if not all, trigger cables do, which also means that while the cable might say that it's a 15 volt cable, you plug it into a certain power supply, you may only get 9 volts out of it, depending on the power supply or battery you plug it into. And this detail right here is the key to understanding these trigger cables and using them, because they're entirely dependent on the USB power delivery supply for all the voltage regulation and everything. You have to know enough about that supply and the standard to understand what you're going to get when you plug it into your device. Now, with those details out of the way, the question that I think really should ask is, what voltage trigger cable should you get? At least assuming you decide after watching this that it might be good to have one. And the easiest answer to that question is the one that matches the voltage of the device that you're going to use it with. But the reality is that's not always, it's not always that simple, and we don't always buy a cable for a specific device. We may just buy it in general. So for most cinema gear, my preference falls are 15 volts, 12 volts, and 9 volts in that order. 15 volt triggers will provide the expected 15 volts when you plug them into a USB PD supply that's rated for 27 watts or more than 27 watts. Moreover, since most of our gear is designed to work with 14.4 volt batteries, and as I already said at the beginning, with the voltage range going up to 16.8 volts, that means that 15 volts is almost always safe to feed into a battery-powered device like that. Now, my second choice is a 12 volt trigger. Now, one thing going against it, and why it's maybe not my first choice, is that 12 volts is not a normative voltage in the USB standard. However, it's also something that's becoming increasingly common on newer USB power delivery batteries and chargers. It's included in all the ones that I've bought in the last year or so, and when I looked at USB-C power delivery capable cinema batteries, like from FX Ion and Small Rig, they all seem to include 12 volts as well. Now, on the flip side, in its favor, it still falls within that 14.4 volt cinema battery voltage range, so anything that uses that will work with a 12 volt input as well. But more importantly, at least when I was buying stuff, is it also is a super common voltage for other DC devices. So it's useful outside of just those camera rig devices or camera side devices. And if, for example, for instance, your source doesn't have a 12-volt mode, you get 9 volts instead, and at least on the camera side of things, that also usually works with everything as well. Now, my last choice in general was 9 volts, and the plus side to 9 volts is that it doesn't require as big of a power supply as the 12 or 15 volt options do. Both of those require 28 watts or more. The 9 volts will run on 16 watts or more. But the downside to the 9 volt stuff is that it's about 7% higher voltage than the maximum voltage of those small camera batteries, the LPE6s, for example. And camera adjacent devices that are specific to those batteries that don't also provide or allow for a larger voltage range may not be able to deal with it. Of course, camera adjacent devices usually have larger voltage ranges, so most of the time they will. Now, that brings me to the final question, which is probably should have been the first question, which is, should you even bother with one of these? And as always, the answer to that is it depends. Personally, I think they're incredibly handy to have, and usually they don't cost that much either. I paid $5 for the one you've seen in this video, and they're not, even in cable form, they're usually $10 or less. And the truth is the one that I'm showing and talking about, I didn't actually buy to use on my camera rig. I bought it for my workbench. There's tons of things that I charge that use USB-C or power that use USB-C, and so I always have a USB-C power delivery charger handy on my bench. I don't always have a 12-volt AC adapter. And since I got this charger or this adapter, it's just easy for me to grab the thing that needs 12 volts, plug it in, and off I go. Now, that said, while I intended to use this only on my bench, it's been in my camera rig almost as much, if not more frequently, powering things like my Ninja display instead of being on my bench recharging batteries that, well, I don't actually need to recharge anymore because the display's powered. So that is USB trigger cables, at least from my perspective as a cinema filmmaker camera guy. I think they're worth having. I think you should probably check them out if you've never seen them before. You might find them useful too. That said, I hope you found this useful, or at least interesting. If you did, let me know by hitting that like button. Also, if this kind of thing seems like it might be your kind of thing, please consider subscribing if you haven't already. Finally, if you'd like to help and support this channel, you can help us for free by liking this video, sharing it with your friends, and leaving a comment with your experiences. Likewise, you can support us by hitting that thanks button or buying yourself something you've always wanted from one of the affiliate links in the description below. And as always, thanks for watching, and I'll see you next time.